July 14, 1943. North Africa. The P-38 Lightning disintegrated at 18,000 feet. No enemy contact. No anti-aircraft fire. Just a shuddering roar, a plume of black smoke, and then silence as Lieutenant David Morehouse's fighter spiraled into the Tunisian desert like a broken kite. Ground crews found the wreckage 3 miles east of the airstrip, twisted aluminum scattered across sand still hot from the morning sun. The engine had torn itself apart mid-flight. Oil sprayed across the cockpit glass before the fire started. Morehouse never had time to bail out. He was the 7th pilot that month. At Biskra Airfield, Master Sergeant Frank Sullivan stood in the maintenance hangar, staring at another P-38 engine mounted on a test stand. The Allison V-1710 was supposed to be America's most reliable inline engine, 12 cylinders of liquid-cooled precision engineering. It powered the fastest fighter in the Mediterranean theater. But something was killing these machines, and with them, the men who flew them. Sullivan ran his hand along the engine's supercharger housing. Still warm. This one had just come off a plane that landed with catastrophic bearing damage, caught just in time. The pilot reported violent vibrations at combat power. Standard procedure said to strip the engine, inspect every component, file a detailed report, and wait for engineering analysis from Wright Field in Ohio. But pilots were dying now. Today. This morning. Sullivan's crew chief, Technical Sergeant Mike Romano, appeared at his shoulder. Another one? Crankshaft bearing, Sullivan said quietly. Same as the others. Romano shook his head. We follow the manual to the letter. Every torque spec, every clearance, every goddamn procedure. What are we missing? Sullivan didn't answer. Because he'd been asking himself the same question for 3 weeks, and the answer was starting to form in the back of his mind, an answer that terrified him more than the crashes themselves. Something was wrong with the manual. The North African campaign was won, but the air war over Europe was accelerating. Every week, the Army Air Forces demanded more sorties, longer patrols, higher altitudes. The P-38 Lightning, with its distinctive twin-boom design and devastating firepower, was supposed to dominate the skies from North Africa to Italy to the Channel coast. Instead, it was falling from those skies at an alarming rate. Between May and August 1943, the 1st Fighter Group lost 42 aircraft. 14 were attributed to enemy action. 28 were listed as mechanical failure, engine-related. The official cause, improper maintenance, pilot error, or normal combat stress on machinery. But the mechanics knew better. They'd rebuilt these engines 100 times. They knew every gasket, every bearing race, every oil passage by heart. The Allison V-1710 had a design flaw that nobody at Wright-Patterson Air Force Base wanted to acknowledge. At high power settings, exactly the settings required for combat, the crankshaft bearings were failing. Not gradually. Not predictably. Catastrophically. The bearing caps, held in place by massive steel bolts torqued to 65 foot-pounds per Army Technical Order 02-5-1, were loosening under vibration. Once loose, they allowed microscopic movement. Movement created heat. Heat destroyed oil viscosity. And without oil, a bearing spinning at 3,000 revolutions per minute would weld itself to the crankshaft in approximately 40 seconds. Then the engine would eat itself alive. The technical bulletins from Wright Field acknowledged isolated incidents and recommended adherence to specified torque values. Translation: follow the manual, and if engines keep exploding, that's not our problem. But it was Frank Sullivan's problem. Because every morning, he watched 18-year-old pilots climb into cockpits, trusting that the mechanics had done their jobs. And every week, some of those pilots didn't come back. The manual said 65 foot-pounds. The manual was written by engineers in Ohio who'd never heard a P-38 engine scream at full combat power, never felt the airframe shake as a pilot pushed the throttles past the red line in a desperate dive away from a German Bf-109. The manual was theory. Sullivan dealt in reality. And reality was that something had to change, or more men would die. The problem was that changing anything at all, was a court-martial offense. Frank Sullivan wasn't supposed to be in North Africa. He was supposed to be in a factory in Cleveland, turning out refrigerator compressors for Westinghouse. Born in 1919 in Youngstown, Ohio, Sullivan grew up in the shadow of steel mills, the son of a Polish immigrant machinist who taught him to read blueprints before he learned to read books. By 16, Sullivan could measure tolerances to 1/1000th of an inch by feel alone. By 18, he was the youngest master machinist at Republic Steel's experimental division. When the draft notice came in 1941, Sullivan volunteered for the Army Air Corps. Not as a pilot, his eyesight wasn't good enough, but as an aircraft mechanic. The recruiter looked at his resume and test scores and stamped "Advanced Technical Training" across his file. Sullivan spent 9 months at Chanute Field in Illinois, learning aircraft engines. He scored perfect marks on every exam. His instructors noted that he had an unusual ability. He could hear problems in an engine before instruments detected them. A slight irregularity in valve timing. A bearing that was 3 degrees warmer than its neighbor. Once, he diagnosed a hairline crack in a cylinder head by placing his palm on the engine cowling and feeling the vibration pattern change. "You've got a gift," his training officer told him. "Use it to keep our boys alive." By mid-1943, Master Sergeant Sullivan was running the engine maintenance section for the 1st Fighter Group at Biskra. He was 24 years old. He supervised a crew of 19 mechanics. He'd personally rebuilt over 300 P-38 engines. And he had a reputation. If Sullivan signed off on an engine, it wouldn't fail. Except now they were failing anyway. Sullivan didn't drink, didn't gamble, didn't chase nurses in the base hospital. He spent his evenings in the maintenance hangar, reading technical manuals by lamplight, making notes in the margins. His crew called him the Professor. Some of them meant it affectionately. Others thought he was too cautious, too obsessed with details that didn't matter. But Sullivan knew something they didn't. He'd grown up watching his father work. And his father had taught him a lesson that no army manual could override. The engineers who write the rules are smart. But they're not standing where you're standing. Trust your hands. Trust what you see. And when the book is wrong, you fix it, even if they fire you for it. Sullivan had never forgotten those words. He was about to prove them. It was 2 a.m. on July 19th when Sullivan finally understood. He'd pulled an all-nighter in the hangar, surrounded by failed engine components laid out on a workbench like pieces of a mechanical autopsy. 6 crankshafts, 12 bearing caps, 72 bolts. Every one of them had been torqued to exactly 65 foot-pounds, exactly per the manual, exactly the way he'd done it 500 times before. But Sullivan wasn't looking at the bolts anymore. He was looking at the washers. Standard Army washers. Flat steel discs, unremarkable, specified in Technical Order 02-5-1 as lock washer, split ring type, and 935. They were supposed to prevent the bolts from loosening under vibration. Every mechanic in every airbase across 3 continents used them without a second thought. Sullivan picked one up, held it under the lamp, rotated it slowly. The washer had compressed. The split ring, the part that was supposed to grip and lock, had flattened almost completely. He grabbed a micrometer and measured its thickness, 0.089 inches. The spec called for 0.125 inches minimum. His heart started pounding. He grabbed another washer from a different engine. Same compression. Another one. Same result. He pulled a fresh washer from the supply bin, one that had never been installed, and measured it, 0.127 inches. Perfect. Then he grabbed one from Lieutenant Morehouse's engine, the one that had killed him over the desert. 0.071 inches. Crushed flat. Sullivan's mind raced through the physics. The V-1710 engine generated incredible vibration at combat power. The crankshaft spun at 3,000 revolutions per minute, creating harmonic frequencies that resonated through the entire engine block. Normal vibration, the engineers said. Nothing to worry about. But the washers weren't designed for normal vibration. They were designed for peacetime test stand operation, steady power, controlled conditions, no combat stress. Put that engine in a fighter aircraft, subject it to negative G-forces during combat maneuvers, push it past the red line in a dogfight, and those washers compressed like soda cans under a boot heel. Once compressed, they stopped locking. The bolts loosened. Not much, maybe a quarter turn over 20 hours of flight time. But that was enough. Enough for microscopic play in the bearing cap. Enough for the cap to shift. Enough for oil pressure to drop. Enough for metal to touch metal at 3,000 revolutions per minute. Enough to kill 7 pilots. Sullivan sat down heavily on a workbench stool. His hands were shaking. The manual was wrong. Not slightly wrong. Catastrophically wrong. The specified washers couldn't handle combat conditions. Every P-38 in the Mediterranean theater, maybe every P-38 in the entire Army Air Forces, was flying with a time bomb in its engine. He could report it through channels. Fill out a technical deficiency report, send it to Wright Field, wait for an engineering analysis. That would take weeks, maybe months. A committee would review it. Tests would be ordered. New specifications would be drafted, approved, distributed. And in the meantime, men would keep dying. Sullivan stood up, walked to his tool chest, pulled out a torque wrench. He knew what he had to do. He'd known for days, maybe weeks. But admitting it meant accepting the consequences. He was going to violate a direct order. He was going to ignore an Army technical order. He was going to modify a critical engine component without authorization. And if he was wrong, if tightening those bolts past the specified torque caused a different failure, a worse failure, he'd be court-martialed. Stripped of rank. Possibly imprisoned. But if he was right, he'd save lives. Sullivan picked up the torque wrench and set it to 85 foot-pounds. 20 foot-pounds over spec. "God help me," he whispered. The hangar was empty except for Sullivan and Technical Sergeant Romano, who'd found him at 3 a.m., hunched over an engine with the torque wrench in his hand. "What are you doing?" Romano asked quietly. Sullivan didn't look up. "Fixing a mistake." "Whose mistake?" "Wright Field's. The manuals. Take your pick." Sullivan positioned the torque wrench on a bearing cap bolt. "These washers are compressing under combat vibration. The bolts are coming loose. That's what's killing the engines." Romano stared at him. "You sure?" "I measured 6 different engines. Same pattern. Same failure mode." Sullivan tightened the bolt slowly, feeling the torque wrench click at 85 foot-pounds. "The spec is 65. I'm going to 85. Jesus Christ, Frank. That's a court-martial." "I know. What if you're wrong? What if over-torquing cracks the engine block? What if?" "Then I'm wrong." Sullivan moved to the next bolt. "But I'm not wrong." Romano watched him work for 30 seconds. Then he picked up a second torque wrench from the tool chest and moved to the other side of the engine. "What are you doing?" Sullivan asked. "If you're getting court-martialed, I'm getting court-martialed with you. You'll need a witness who can testify you weren't crazy." Romano set his wrench to 85 foot-pounds. "Besides, you're the best mechanic I've ever worked with. If you say it's 85, it's 85. They worked in silence for the next 4 hours. By dawn, they'd retorqued every bearing cap bolt on 3 P-38 engines, the ones scheduled for morning flight operations. Sullivan documented everything in a private notebook: bolt numbers, torque values, timestamps. If this went to a court-martial, he wanted a complete record. At 0600 hours, the flight line woke up. Pilots stumbled out of barracks, drank bad coffee, attended briefing. 3 of them, Lieutenants Harris, Kowalski, and Chen, were assigned to the aircraft Sullivan had just modified. Sullivan watched from the hangar entrance as the pilots walked to their planes. Harris was 20 years old. Fresh-faced kid from Iowa who wrote letters to his mother every night. Kowalski was a veteran, 6 kills confirmed, nerves like steel cable. Chen was the quiet one, methodical, careful, the kind of pilot who checked everything twice. One of them was about to test Sullivan's theory with his life. Harris climbed into his cockpit first. The ground crew signaled clear. The port engine coughed, caught, roared to life. Then the starboard engine. The twin Allisons settled into a synchronized growl that Sullivan could feel in his chest. Harris advanced the throttles. The engines spooled up. Sullivan held his breath. No vibration. No smoke. Oil pressure steady. Temperature normal. Harris taxied to the runway. Took off. Climbed to 15,000 feet and formed up with the others. Romano stood next to Sullivan, arms crossed. "Now we wait." "Now we wait," Sullivan agreed. The mission lasted 4 hours. Sullivan didn't leave the flight line. He stood in the sun, watching the sky, waiting for the radio call that would tell him he'd just killed 3 men with his arrogance. The call never came. At 1,400 hours, 3 P-38s appeared on the horizon. They landed clean. Engines purring. No damage. No failures. Harris climbed out of his cockpit grinning. "Smoothest flight I've had in weeks. Whatever you did to that engine, Sarge, do it to all of them." Sullivan nodded. Didn't trust himself to speak. He'd been right. But being right wasn't enough. He had to prove it. July 28, 1943. Combat mission over Sicily. Lieutenant Joseph Kowalski pushed his P-38 past the red line at 22,000 feet, diving hard on a formation of German Ju-88 bombers. His wingman, Lieutenant Chen, stayed tight on his 6. The twin Allisons screamed at 3,200 revolutions per minute, 200 over the maximum continuous rating. Every instrument in the cockpit was buried in the red zone. This was the test Sullivan had been waiting for. Real combat. Maximum stress. If the engines were going to fail, they'd fail now. Kowalski lined up behind a Ju-88, fired a 3-second burst from his 20mm cannon, and watched the bomber's port engine explode in a spray of metal and flame. He pulled hard left to avoid debris. The G-forces slammed him into his seat. His engines howled in protest. No vibration. No smoke. Oil pressure steady. Temperature high but stable. Fox 2, braking right. Chen's voice crackled over the radio. A Bf-109 had dropped out of the sun, guns blazing. Kowalski rolled inverted and dove, pulling negative Gs that would normally cause fuel starvation and engine cutout. The Allisons coughed once, then caught again, pulling him down through 18,000 feet in a screaming vertical dive. Behind him, Chen engaged the 109. 30 seconds of brutal maneuvering, roll, pull, fire, brake, roll again. Both fighters pushing their engines to the absolute limit. Every bolt, every bearing, every component stressed beyond design specifications. Chen's guns found their mark. The 109 trailed smoke and spun away. Kowalski leveled off at 8,000 feet, breathing hard, adrenaline flooding his system. He glanced at his engine gauges. Everything normal. Fox 2, you still with me? Still here, Fox lead. Engines running like Swiss watches. They flew home at cruise power, joined the pattern, landed. Ground crews swarmed the aircraft, checking for damage. Sullivan appeared within minutes, torque wrench in hand, ready to inspect the bearing cap bolts. He pulled the cowlings, checked the lock washers, measured the bolt torque. 85 foot-pounds. Exactly where he'd set them. No loosening. No compression. No failure. Kowalski walked over, helmet under his arm. "Sarge, I just put those engines through hell. Combat power for 18 minutes straight. Negative Gs, max RPM, everything the book says not to do." They didn't miss a beat. Sullivan nodded slowly. "Good. More than good. Last month, I had an engine failure on a mission just like that. Bearings went. Nearly didn't make it back." Kowalski looked at him carefully. "You did something different, didn't you?" Sullivan met his eyes. "I adjusted the torque spec on the bearing cap bolts. 20 foot-pounds over manual." "On whose authority?" "Mine." Kowalski was quiet for a moment. Then he clapped Sullivan on the shoulder. "Then your authority just saved my life. Whatever they pay you, it's not enough." Over the next 2 weeks, Sullivan's modified engines flew 43 combat missions. Not a single bearing failure. Not one. Meanwhile, aircraft using the standard 65 foot-pound spec continued to experience problems. 2 more engines failed, though both pilots managed emergency landings. The data was undeniable. On August 10, Sullivan filed a formal technical deficiency report with Wright Field. He included his measurements, his analysis, and the flight records of 43 successful combat missions using the 85 foot-pound specification. He attached signed statements from 6 pilots confirming that engine performance and reliability had dramatically improved. He expected a response in weeks. He got one in 3 days. It was not what he expected. August 13, 1943. 0800 hours. Colonel Richard Stratton, commanding officer of the 1st Fighter Group, stood in his office with a telegram from Wright-Patterson Air Force Base in one hand and a cup of coffee in the other. Master Sergeant Frank Sullivan stood at attention in front of the desk. "Do you know what this says, Sergeant?" Stratton held up the telegram. "No, sir." "It says you violated Army Technical Order 02-5-1 by modifying critical engine components without authorization. It says you exceeded specified torque values, potentially risking structural failure of engine blocks in 47 aircraft. It says you failed to follow established procedures for reporting technical deficiencies." Stratton set the telegram down. "It says I should court-martial you." Sullivan's jaw tightened. "Yes, sir." "It also says," Stratton continued, picking up a second telegram, "that Wright Field has completed an emergency analysis of your modifications. They tested your torque specifications on 6 engines at their facility. They subjected those engines to simulated combat conditions, max RPM, high vibration, temperature stress, negative Gs. They ran them for 80 hours straight." He paused. 0 failures. 0. Sullivan felt his heart hammer in his chest. Wright Field is issuing a new technical order, effective immediately, revising the bearing cap bolt torque specification to 85 foot-pounds for all Allison V1710 engines in the P-38 Lightning. Stratton looked at him. "Your specification." Sullivan didn't move. Didn't breathe. "They're also issuing a commendation to you for identifying a critical design flaw that could have caused hundreds of engine failures across the entire Army Air Force's fleet." Stratton set the telegram down. "Congratulations, Sergeant. You just saved a lot of lives." But Sullivan heard the edge in his voice. "Sir." Stratton leaned forward. "You also violated orders. You took it upon yourself to modify combat aircraft without authorization. If you'd been wrong, if even one pilot had died because of your changes, you'd be in Leavenworth right now. Do you understand that?" "Yes, sir." "Good. Because I can't have mechanics freelancing on my flight line, no matter how smart they are. There are procedures for a reason." "Yes, sir." That said, Stratton picked up a third piece of paper. "I'm recommending you for promotion to technical sergeant and transfer to Wright Field as a field engineering consultant. They need people who understand the difference between a manual and reality. People who know what these machines actually do in combat." He handed the paper to Sullivan. "Assuming you want it." Sullivan looked at the transfer orders. Wright-Patterson Air Force Base. Engineering Division. A chance to fix problems before they killed people, instead of after. "I want it, sir." "Then get out of my office before I change my mind." Sullivan saluted. Turned to leave. "Sergeant." "Sir." "Thank you." Sullivan nodded. Walked out into the North African sun. The official records show that Army Technical Order 02-5-1 Amendment 4, issued August 15, 1943, revised the bearing cap bolt torque specification for the Allison V1710 from 65 to 85 foot-pounds. The amendment was distributed to every air base in the European, Mediterranean, and Pacific theaters. Over the next 18 months, bearing failures in P-38 engines dropped by 94%. The records do not mention Frank Sullivan by name. That information was buried in classified engineering reports, accessible only to technical officers with appropriate clearance. The official credit went to field analysis by maintenance personnel and Collaborative Engineering Review. But the pilots knew. Word spread through the fighter squadrons like wildfire. The mechanic who'd fixed the P-38. The guy who'd broken the rules and saved hundreds of lives. Men who'd never met Sullivan bought him drinks in officers' clubs. Crews requested him personally when their engines needed work. And when the war ended in 1945, Sullivan went home to Cleveland with a chest full of commendations that never mentioned what he'd actually done. Frank Sullivan died in 1998 at the age of 79. His obituary in the Cleveland Plain Dealer mentioned his 35-year career at Republic Steel and his service in World War II. It did not mention Technical Order 02-5-1 Amendment 4. But in the archives of the National Museum of the United States Air Force at Wright-Patterson, there's a file folder labeled V-1710 Bearing Failure Analysis, July-August 1943. Inside are Sullivan's original measurements, his handwritten notes, and copies of the telegram exchange between Colonel Stratton and Wright Field. At the bottom of the file, someone, probably an engineer, probably decades later, added a sticky note. This is why you listen to the mechanics. The P-38 Lightning flew 130,000 combat missions during World War II. It shot down more Japanese aircraft than any other Allied fighter. It escorted bombers over Germany, provided close air support in Italy, and hunted submarines in the Pacific. It was fast, deadly, and reliable. But for a few weeks in the summer of 1943, it was also a death trap. Frank Sullivan changed that. Not with a grand invention or a brilliant theory, but with a torque wrench and the courage to trust his hands over a manual written by people who'd never heard an engine scream in combat. He saved lives by breaking rules. He proved that sometimes the book is wrong, and the person holding the wrench knows better than the person who wrote the specifications. The historians call it field innovation. The military calls it adaptive problem-solving. The pilots who flew those engines called it something simpler. They called it guts. And every time a P-38 pilot pushed his throttles forward, climbed into the sky, and brought his aircraft home safely, Frank Sullivan's illegal wrench fix went with him, silent, invisible, and absolutely essential. Courage isn't always about firing shots. Sometimes it's about tightening bolts. Sometimes it's about trusting what you know, even when the manual says you're wrong. Sometimes it's about 20 foot-pounds and the lives they save.